Look at the next question. Which of the following functions are strictly decreasing on 0 to pi by 2? Cos x, cos 2x, cos 3x, tan x. Let's take one by one. Which of these functions are decreasing on 0 to pi by 2? So first one, cos x. F of x is equal to cos x. So what is the first method? Find f dash of x, derivative of cos x with respect to x. That is minus sin x. Right? Okay. So here we have to check whether this f dash of x less than 0 or greater than 0. For that we have to check sin x is less than 0 or greater than 0 in the interval 0 to pi by 2. We know that the interval, all the points in the interval 0 to pi by 2 lies in the first quadrant, right? 0 to pi by 2. All the values in the interval 0 to pi by 2 lies in first quadrant. And we know that all the trigonometric functions are positive in the first quadrant. That is, sin x is positive in first quadrant. That is, sin x is greater than 0 in the interval 0 to pi by 2. Okay. So what about minus sin x? Minus sin x is negative, right? Minus into positive, that is negative. So here we can write sin x is positive in 0 to pi by 2. Then f dash of x. F dash of x is nothing but minus sin x. Sin x is positive, so minus sin x is negative. Therefore, f dash of x is negative in 0 to pi by 2. Therefore, f dash of x is less than 0. Hence, we have got f dash of x less than 0, not less than or equal to 0. Why? Because our interval is open interval. Here 0 is not included. We know that sin 0 is 0, but here 0 is not included. Okay. Therefore, sin f dash of x is equal to 0 will not come. Only f dash of x less than 0. Okay. Therefore, hence the given function f of x is strictly decreasing. Okay. Not only decreasing, strictly decreasing. Strictly decreasing in 0 to pi by 2. Okay. Therefore, this first function cos x is strictly decreasing on 0 to pi by 2. Okay. Now let's check second one, whether it is increasing or decreasing on the interval 0 to pi by 2. Second function f of x is equal to cos 2x. Here x belongs to 0 to pi by 2. Okay. Then first step is finding derivative. F dash of x is equal to derivative of cos 2x is minus sin 2x into derivative of 2x is 2. So minus 2 sin 2x. Okay. So here we have to check this sin 2x is less than 0 or greater than 0 in the interval 0 to pi by 2. Here when it is 2x, not x, okay. So when x belongs to, here x belongs to 0 to pi by 2, okay. Then 2x belongs to, multiply, see, multiply by 2, 0 into 2, 0, okay. 2 into pi by 2 is pi, okay. So when x belongs to 0 to pi by 2, 2x belongs to 0 to pi, okay. So here we have to check whether the sin x is positive or negative in the interval 0 to pi. Here we know that all the values in the interval 0 to pi lies in first and second quadrant, right? All the values in the interval 0 to pi lie in the interval, in the quadrant, first quadrant and the second quadrant, right? Because 0 to pi by 2 pi, see, 0 to pi by 2 to pi. So it lies in the first and second quadrant, okay. And we know that in first quadrant sin x is positive, okay. All trigonometric functions are positive. And in second quadrant sin x and cosec x are positive, right? Only sin x and cosec x are positive. Therefore, in first quadrant and second quadrant sin x is positive, right? So here we can say sin 2x is positive in the interval 0 to pi by 2. Okay, sin x is positive in the interval 0 to pi. Therefore, sin 2x is positive in the interval 0 to pi by 2. So, since it is positive, minus 2 into sin 2x is nothing but it is negative, right? Okay. Sin 2x is positive in 0 to pi by 2. Therefore, okay, then f dash of x is negative. Hence, f of x is strictly decreasing, okay, because, or we can write f dash of x is less than 0, okay, less than 0, not less than or equal to 0 since it is an open interval, okay. So, f of x is strictly decreasing on 0 to pi by 2, okay. Therefore, the function f of x is equal to cos 2x is strictly decreasing on the interval 0 to pi by 2. Let's check third one, whether it is decreasing or increasing in the function in the interval 0 to pi by 2. F of x is equal to cos 3x. Okay, f of x is equal to cos 3x. So what is f dash of x? Minus 3 sin 3x, right? Derivative of cos 3x is minus sin 3x into derivative of 3x is 3. So minus 3 sin 3x. Okay. So here x belongs to 0 to pi by 2. Okay. So here we have to check whether this sin 3x is less than 0 or greater than 0 in the interval 0 to pi by 2. So when x belongs to 0 to pi by 2, what about 3x? 3x belongs to 3 into 0, 0, 3 into pi by 2, 3 pi by 2. Okay. So 3x belongs to 0 to 3 pi by 2. Okay, now here we have to check the function sine is increasing or less than 0 or greater than 0 in the interval 0 to pi by 2. Okay, so let's come here. Here 0 to 3 pi by 2. See, all the values lie in the quadrant, first quadrant, second quadrant, third quadrant. Okay, 0 to pi by 2 lie in the first quadrant, second quadrant, third quadrant. Okay, 0 to pi by 2. And in first quadrant, sin x is positive, right? In second quadrant, sin x is positive. But in what about in third quadrant? In third quadrant, only tan and cot are positive, right? Tan and cot are positive. Sin x is negative in third quadrant. Okay. Therefore, here we can say this sin x can be positive or negative in the interval 0 to 3 pi by 2. Okay, why? Because in the first quadrant, sin x is positive, second quadrant, sin x is positive, third quadrant, sin x is negative. Okay, so sin x can be positive or negative in the interval 0 to 3 pi by 2. Okay, so here sin 3x can be positive or negative in the interval 0 to pi by 2. Okay, sin 3x can be positive or negative in the interval 0 to pi by 2. Therefore, f dash of x minus of 3 sin 3x minus sin 3x, that's also it can be positive or negative. If sin 3x is positive, then f dash of x is negative. If sin 3x is negative, then f dash of x is positive, right? So here we can write f dash of x is f dash of x can be positive or negative. Hence, f of x is equal to cos 3x is neither increasing, okay, because it can be positive or negative. Therefore, what is the result? F of x, that is given function cos 3x is neither increasing nor decreasing in the interval 0 to pi by 2. Neither increasing nor decreasing on 0 to pi by 2. Next, fourth one, tan x. Given function is tan x. So here we have to check whether this tan x is increasing or decreasing on the interval 0 to pi by 2. F dash of x is equal to derivative of tan x with respect to x is sec square x. Sec square x. Okay. So here we have to check this sec square x is positive or greater than 0 or less than 0 in the interval 0 to pi by 2. See, sec square of a trigonometry function, right? So square of a function, that is always positive, right? And we know that in 0 to pi by 2, in the interval 0 to pi by 2, all the functions are positive. Therefore, sec x is positive in the interval 0 to pi by 2. So here we can say sec square x is positive or greater than 0 on 0 to pi by 2. Therefore, f dash of x is greater than 0. Okay, f dash of x is greater than 0. Hence, f of x or the function tan x is strictly increasing. Okay, since f dash of x greater than 0, the function tan x is, that is f of x is equal to tan x is strictly increasing on 0 to pi by 2. Okay, hence tan x is strictly increasing on 0 to pi by 2. So here we have got, see what was the question? Which of the following functions are strictly decreasing on 0 to pi by 2? So only two functions, right? Cos x and cos 2x are strictly decreasing on the interval 0 to pi by 2. Next question, on which of the following intervals is the function f given by f of x is equal to x raised to 100 plus sin x minus 1 strictly decreasing? Okay, so here we have to check the given function is strictly increasing on which of these intervals. Okay, so here let's check one by one. First one is 0, 1. Okay, when x belongs to 0, 1. Our f of x is equal to x raised to 100 plus sin x minus 1. What is f dash of x? F dash of x is equal to derivative of x raised to 100 is 100 x raised to 99 plus sin x derivative is cos x minus 1 derivative is 0. Okay. So it is f dash of x. Okay. So first interval is x belongs to 0 to 1. See here, see when we substitute, when any values between 0 and 1 substituted for x, it will be greater than 0 itself, because no negative values in between 0 and 1, right? No negative values. So here it is always greater than 0 in this interval, right? Then what about cos x? Cos x is also greater than 0, right? So here the 0 to 1, you will get cos x value, that is cos 0 is 1. So and cos 1, that is also greater than 0. So obviously this f dash of x is positive, greater than 0. Okay. That is, we can write 100 into x raised to 99 is greater than 0 and cos x is greater than 0 in 0 to 1. Okay. Therefore, f dash of x is greater than 0. Hence, here f of x is strictly increasing, right? Since f dash of x greater than 0, f of x is strictly increasing in 0 to 1. Okay. Second interval is pi by 2 to pi. Okay. Here x belongs to pi by 2 to pi. Okay. So here also we have to check whether this f dash of x is less than 0 or greater than 0. So for that we have to check one by one for these two terms. Okay. So first term is, see, 100 x raised to 19. I can write 100 x raised to 19 is always greater than 100. Right? That is 100 into a positive number. That is always greater than 100. Right? Okay. Then what about cos x? In the interval, this one. Cos x, see here, the values of cos x is between Cos pi by 2 is 0. Cos pi by 2 is 0. Cos pi is minus 1. So minus 1 less than cos x less than 0. Right? That is values of cos x are between 0 and minus 1 and 0. Okay. So here totally we can write, because here we have to check this one, right? F dash of x less than 0 or greater than 0. So f dash of x is equal to first term, this one, right? 100 x raised to 99 plus cos x. Okay. So here we know that this first term 100 x raised to 99 is always greater than 100, plus then what about cos x? See, cos x is greater than minus 1. So here greater than minus 1 less than 0. So cos x is negative. Okay, cos x, the value of cos x is negative, but it is greater than minus 1. Okay, just think, greater than minus 1. Greater than minus 1 means the values like minus 0.9, minus 0.8, minus 0.7, minus 0.5. Okay, so such numbers. So here 100 plus a negative number greater than minus 1. See, if you add such numbers to this with this 100, you will get, obviously you will get a positive number, right? That is 100 plus the minus of a small numbers, that will be positive number, right? So here, so we can write, hence f dash of x is always greater than 0. Okay, because see, this term is greater than 100 plus cos x is a negative number. Why? Because see, the values of cos x between 0, minus 1 and 0. That means cos x is less than 0 means cos x is negative. Okay, value of cos x is negative. But it is greater than minus 1. The negative value, but it is greater than minus 1. Okay, so greater than minus 1 means the minus of a small value, right? Suppose, see, 0 to 1. Sorry, minus 1. Okay, so less than minus 1 means it is minus 2. Minus 2 is here, okay, less than minus 1. Greater than minus 1 means, see, minus 0.9, minus 0.8. It is minus 2, minus 1, minus. These are the less than, means the values less than minus 1. Greater than minus 1 means the values goes right side, okay. So 0.9, minus 0.8, minus 0.7, like that, okay. So if we add such numbers here with this 100, we will get a positive number itself, right? So here f dash of x is greater than 0. Hence f of x is strictly increasing in pi by 2 to pi. Okay. What about third interval 0 to pi by 2? X belongs to 0 to pi by 2. Okay, so x belongs to 0 to pi by 2. Here f dash of x, okay, 100 x raised to, let's take these two terms, okay, one by one. 100 x raised to 99, it's always greater than 0, right? Because our x values are positive. So it is always greater than 0. And what about cos x? Cos x, see here, our interval is 0 to pi by 2. It lies in first quadrant. Since cos x is positive in the first quadrant, we can say cos x is positive, right? That is, cos x is greater than 0 in 0 to pi by 2. Therefore, f dash of x is greater than 0 in 0 to pi by 2. Hence, f of x is strictly increasing in 0 to pi by 2. So, what was our question? On which of the following intervals is the function f given by f of x is equal to x raised to 100 plus sin x minus 1 strictly decreasing? So, here in this interval the function is increasing, second also increasing, third also strictly increasing. So, the answer is none of this. Okay, answer is none of this. Find the least value of a such that the function f given by f of x is equal to x square plus ax plus 1 is strictly increasing on 1 to 2. So here we have to find the least value of a. Okay, what is the least value of a when the given function is strictly increasing on 1 to 2? So first of all, write our function f of x is equal to x square plus ax plus 1. Here x belongs to 1 to 2. 1 to 2. Then find f dash of x, 2x plus a. Okay. So here it is given f dash of x is greater than 0. Given function is strictly increasing on 1 to 2 means f dash of x is greater than 0 when x belongs to 1 to 2. Okay. That is 2x plus a greater than 0. Here f dash of x is greater than 0 means 2x plus a greater than 0. That implies 2x greater than minus a. Take a here. Okay. That implies x greater than minus a by 2. When x belongs to, see, x belongs to the interval 1 to 2, that can be written as, means values of x are between 1 and 2, right? So that can be written as 1 less than x less than 2, right? So here the least value of x is 1. Okay, substitute x is equal to 1. Here we will get minus a by 2 is equal to 1. That implies minus a is equal to 2. That implies a is equal to minus 2. Okay, because see here least value of x is 1. Here x greater than minus 1 by 2, right? Minus a by 2. X greater than minus a by 2. So take the least value of x, that is 1. So equate to this, minus a by 2 is equal to 1. If minus a by 2 is equal to 1, then what is the value? Here, see, x is greater than 1, right? X is greater than minus a by 2. So put x is equal to 1, so that what is the value of a? A is equal to minus 2. So here, the minus 2 is the least value of a. Okay, here we have taken the least value of x, that is 1. Okay, and substitute. So minus a by 2 is equal to 1 because minus a by 2 less than x. Okay, so here after simplifying we have got a is equal to minus 2. So minus 2 is the least value of a when this function is strictly increasing on 1 to 2. Okay, least value of a is equal to minus 2. Let I be any interval disjoint from minus 1 to 1. Prove that the function f given by f of x is equal to x plus 1 by x is strictly increasing on I. So here, see, we have to prove this function is strictly increasing on I. See, what is the interval I? This interval is not containing the interval minus 1 to 1. That means the I is nothing but r minus 1 to 1. Okay, this interval excluding this interval minus 1 to 1. Okay, so here f of x is equal to x plus 1 by x. F dash of x is equal to derivative of x is 1, derivative of 1 by x is minus 1 by x square. So this can be written as x square minus 1 divided by x square. Right? X square minus 1 divided by x square. We know that if f dash of x greater than 0, then the function is strictly increasing, right? So here, when it is greater than 0, that is, see, if x square greater than 1, it will be positive, right? For example, x square is equal to 2, 2 minus 1, 1, 1 by 2, right? So here you will get positive value. If x square less than 1, because since it is 1, right? So x square less than 1, suppose x square is equal to 0. So 0 minus 1, you will get negative value. So it is positive only if x square greater than 1, right? So f dash of x greater than 0 when x square greater than 1, right? So when x square is greater than 1, see, x square is greater than 1 when x belongs to r minus 1 to 1. See, only in these values x square less than 1. Okay, see here minus 1 to 1, the values minus 1 to 1. See, here minus 1 and 1 are not included. Okay, so the close values near to minus 1 and 1. See, 0 included, right? See, if you substitute x is equal to 0, x square is equal to 0. So 0 minus 1, so it will be minus, right? So minus. So here if you substitute any values between -1 and 1, you will get negative value, that is f dash of x less than 0. Okay. So here when x square greater than 1, see x square greater than 1 only if x belongs to r minus -1 to 1. Okay. All the values except these values. Okay. X belongs to all the real numbers except this -1 to 1. Therefore, hence f of x is, so here we can write f dash of x, okay, f dash of x greater than 0 when x belongs to r minus -1 to 1. Okay. Therefore, this f dash of x is always positive when x belongs to r minus -1 to 1, except this -1 to 1. Okay. Hence, f of x is strictly increasing on I. Okay. That is, what is I? I is nothing but disjoint from -1 to 1. Disjoint from -1 to means -1 to 1 means that interval does not contain this interval. Okay, -1 to 1. Okay. Prove that the function f given by f of x is equal to log sin x is strictly increasing on 0 to pi by 2 and strictly decreasing on pi by 2 to pi. Very simple question. So f of x is equal to log sin x. It is the given function. Let's find the f dash of x. F dash of x is equal to derivative of log sin x 1 by sin x into derivative of sin x cos x. That is, cos x by sin x is nothing but cot x. Okay. So here f dash of x is equal to cot x. Okay. So here we have to prove this function, that is f of x is strictly increasing on 0 to pi by 2. That means we have to prove f dash of x is greater than 0 in the interval 0 to pi by 2. So that means we have to check whether this cot x is increasing. Okay, we have to prove. Okay, we have to prove this cot x is greater than 0 in the interval 0 to pi by 2. We know that the 0 to pi by 2 lies in first quadrant, right? 0 to pi by 2. 0 to pi by 2 lies in the first quadrant, and in the first quadrant cot x is positive, right? In the first quadrant all 6 trigonometric functions are positive, right? So here cot x is also positive. Therefore, cot x is greater than 0 in the interval 0 to pi by 2. Cot x is greater than 0 in 0 to pi by 2. Okay. Therefore, f dash of x is greater than 0 in 0 to pi by 2. Hence, f of x is strictly increasing on 0 to pi by 2. Then, what about pi by 2 to pi? Here, f dash of x is cot x. So here we have to prove this cot x is less than 0 in the interval pi by 2 to pi. See, pi by 2 to pi, second interval, right? Pi by 2, the interval pi by 2 to pi lies in the second interval. In the second interval, we know that only sin x and cosec x are positive, and remaining all the trigonometric functions are negative, right? That means cot x is negative in second quadrant. Okay. Therefore, here we can write cot x is less than 0 in pi by 2 to pi. Okay, pi by 2 to pi. Pi by 2 to pi. Pi by 2 to pi, that lies in second quadrant. Okay, pi by 2 to pi lies in second quadrant. In second quadrant, cot x is negative. Therefore, cot x is less than 0 in pi by 2 to pi. Therefore, then f dash of x less than 0 in pi by 2 to pi. Hence, f of x is strictly decreasing on pi by 2 to pi. Okay, f of x is strictly decreasing on pi by 2 to pi. Next, similar question. Prove that the function f given by f of x is equal to log cos x is strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2 to pi. So here, write f of x is equal to log sin x. F dash of x is equal to derivative of log sin x is log cos x is 1 by cos x, derivative of cos x is minus sin x. That is minus tan x. Okay. So here we have to prove f dash of x is less than 0 on the interval 0 to pi by 2. Okay, we know that 0 to pi by 2 lies in first quadrant. In first quadrant, tan x is positive. In the first quadrant, tan x is positive, but minus tan x is negative. Okay. So here in the first quadrant, here we can write tan x is greater than 0 on 0 to pi by 2. Okay. Therefore, minus tan x is less than 0 on 0 to pi by 2. That is, therefore, f dash of x less than 0 on 0 to pi by 2. Hence, f of x is, since f dash of x less than 0 on 0 to pi by 2, f of x is strictly decreasing, right? Is strictly decreasing on 0 to pi by 2. Okay. Then what about pi by 2 to pi? See, let's take here we have to prove this function is strictly increasing on pi by 2 to pi. Pi by 2 to pi lies in second quadrant. In second quadrant, tan x is negative, right? In second quadrant, only sin x and cosec x are positive. So other trigonometric identities are negative, right? That is, tan x is negative in the second quadrant. So tan x is less than 0 on pi by 2 to pi. Okay. That is, f dash of x is, tan x is less than 0. Okay. So that means tan x is negative. So f dash of x is minus into minus, that is positive, right? So here f dash of x is greater than 0 on pi by 2 to pi. Understood, right? That is, tan x is less than 0, but here our f dash of x is nothing but minus tan x. So minus of minus, that is plus. Okay. So greater than 0. F dash of x is greater than 0 on the interval pi by 2 to pi. Since f dash of x is greater than 0, the given function f of x is strictly increasing, right? F of x is strictly increasing on pi by 2 to pi. Hence it is proved. Prove that the function given by f of x is equal to x cube minus 3x square plus 3x minus 100 is increasing in R. F of x is equal to x cube minus 3x square plus 3x minus 100. Let's find f dash of x. Okay, here we have to prove this function is increasing in R. Okay, f dash of x is equal to 3x square, derivative of x cube is 3x square, minus 3 into 2x, 6x, plus 3, derivative of 100 is 0. Here 3 is common, let's take it out. 3 into x square minus 2x plus 1. Okay, so here we have to check whether this is greater than 0. Sorry, here not checking, here we have to prove it is greater than 0, right? So we have to make it in the form of x plus a whole square. Okay, so here we can write very easily, we can write x square minus 2x plus 1 is nothing but x minus 1 whole square, right? X minus 1 whole square. See, x minus 1 whole square, 3 is positive, okay, x minus 1 whole square. If we substitute any values for x, any values, okay, in R, so any values for x in set from the domain, that is set of real numbers. So here it is whole square, right? So we will get only positive. And if x is equal to 1, when we substitute x is equal to 1, 0, 1 minus 1, 0. So here we will get 0, right? So here this will be always greater than or equal to 0. Okay, greater than or equal to 0 when in x belongs to R. Okay, for all set of real numbers, for any numbers in the domain, that is set of real numbers, here this x minus 1 whole square is always greater than or equal to 0. When x is equal to 1, it will be 0, right? So here we can write 3 into x minus 1 whole square is greater than or equal to 0 when x belongs to when x belongs to R. Okay. Therefore, since it is greater than or equal to 0, this function is increasing, only increasing in R, not strictly increasing. See here we have to prove increasing in R, right? Okay, so f dash of x is greater than or equal to 0. Therefore, f of x is increasing in R. The interval in which y is equal to x square into e raised to minus x is increasing minus infinity to infinity, minus 2 to 0, 2 to infinity, 0 to 2. Okay. Let's check in which interval the given function is increasing. Okay. For that, first of all, let's write the given function y is equal to x square into e raised to minus x. Then find its derivative y dash or dy by dx, that is equal to, apply product rule. First function x square into derivative of second function, that is derivative of e raised to minus x is e raised to minus x into derivative of minus x, that is minus 1. So minus x square into e raised to minus x plus e raised to minus x into derivative of x square is 2x. So here e raised to minus x into x is common, so let's take it out. E raised to minus x into x, here remaining 2 minus x, right? So to find the critical values, we have to find the critical values, right? So because we have to find in which interval the function is increasing. Okay, so for that we need to find the values of x. For that, y dash is equal to 0. That implies e raised to minus x into 2 minus x is equal to 0. That implies, see here, e raised to minus x. E raised to minus x exponential function is always greater than 0. Okay, e raised to minus x, it is not equal to 0, it is always greater than 0. Therefore, it is not equal to 0. Okay, so it is positive, and here x is equal to 0 and 2 minus x is equal to 0, that implies x is equal to 2. So the critical values are 0 and 2. Okay, then next, see, let's divide this x is equal to 0 and x is equal to 2, divide the interval, that is minus infinity to infinity, that is 0 to, sorry, first starting from minus infinity to 0, 0 to 2 and 2 to infinity. Okay. Now let's check one by one. In this interval, minus infinity to 0, here it is our y dash, okay, f dash of x, that is y dash, e raised to minus x into 2 minus x. Okay, e raised to minus x, that is always positive, right? So it is positive, and x, see, in the interval, the values in the interval minus infinity to 0 are always positive. Sorry, always negative, right? All the values are negative, right? All the values between minus infinity and 0 are negative. Okay, so here that is x is negative. Then 2 minus x. Here when we substitute any negative values, here we will get positive, right? Because minus x, 2 minus, suppose for example, substitute minus 3. 2 minus 3, it will be plus 5, right? So here it is positive. Okay, 2 minus x will be positive because if any values substituted minus infinity to 0, okay, any values between minus infinity to 0 substituted for x, it will be this 2 minus x term greater than 0, right? So that is positive. So plus into minus, minus into plus, minus. So that is total, it is minus, means f dash of x or y dash. Okay, here it is y dash. Y dash less than 0. Then next interval 0 to 2. Okay, 0 to 2, in the interval 0 to 2, here it is positive. Okay, first term, that is e raised to minus x, exponential function is always greater than 0. So next x, 0 to 2, it is all the values between 0 and 2 are positive, right? So it is positive. Okay, then what about 2 minus x? See, when we substitute x is equal to 2, it will be 0. 0 to 2 means the maximum value is 2. So when we substitute x is equal to 2, it will be 0. So when we substitute the values less than 2 and greater than 0, it will be less than 0, right? For example, take any value between 0 and 2, 1, okay? So substitute x is equal to 1, you will get 2 minus 1, that is 1, okay? And here, okay, see here, when you substitute x is equal to 2, you will get 0. But here when we substitute x is equal to 0, you will get a positive value. When we substitute x is equal to 1, that is 2 minus 1, a positive value itself, okay? So 2 minus x will be positive. It is positive, okay, understood? That is, e raised to minus x is always positive. X is positive because all the values between 0 and 2 are positive. Okay, and this 2 minus x, see, if you are confusing, just take one value between this interval, okay, value containing in this interval, that is 0 and 2, between 0 and 2, 1 is there. So substitute x is equal to 1, 2 minus 1 is 1, that is positive, therefore it will be positive, okay. So all are positive, therefore total it is positive, so y dash is greater than 0. Then in the interval 2 to infinity, here all the values are between 2 to infinity are positive, right? And it is greater than 2. So here first is always positive. Second, since these values are positive, it is always positive. Okay. Then what about this one? 2 minus x. Here we substituting, when we substitute x is equal to 2, it will be 0. And when we substitute x is equal to greater than 2, that means, see, it is 2 minus x, right? Okay, so if you substitute 5, it will be 2 minus 5. 2 minus 5 will be minus 3. So, if you substitute any values greater than 2, here this term will be less than 0. That is negative. Okay, why? Because, see, substitute minus 50. So, it will be minus 48. So, these any values between, that is greater than 2, substituted for this x, then it will be, this term will be less than 0, okay, that is negative. Or you can give examples, see, take any values and substitute, okay. For example, take x is equal to 3, 3 is greater than 2, right? 2 minus 3 is minus 1, so it will be minus, okay. So plus into plus, minus, minus into minus, sorry, plus into plus, plus, plus into minus, minus, okay, it is minus. So y dash is less than 0. Okay, so here what we have to find? The interval in which the function y is equal to x square e raised to minus x is increasing in, okay, increasing in which interval? Increasing in the interval 0 to 2. Okay, so D is the answer. Okay. See here, we have got y dash is greater than 0. Y dash is greater, since y dash greater than 0, so y dash is greater than 0 in the interval 0 to 2. Therefore, given function y is equal to x square e raised to minus x is increasing in the interval 0 to 2. Okay, so D is the answer.